All right, hey Connor and whoever's gone fifth period watching this, we are going to do chapter 2 and chapter 3 today and get hopefully another 15 done. This is day 2 of semester review. So here we go. Chapter 2 starts us off with patterns. It says make a conjecture. What is a conjecture, by the way?
An idea.
An idea about, or a conclusion about the pattern, right? Conjecture. Okay, and then they want the next term in the sequence, so make sure you're answering both of those questions, okay? All right, so what's the conjecture? What are we doing in the pattern?
4.
You're adding 4 each time, okay? So conjecture is, what just happened to my pen? Reconnect, plus 4.
Plus you.
Oh, we're having technical difficulties. Plus 4 is the conjecture. Next term in the sequence?
9.
9, there you go, perfect. Okay, 17, what is the truth value of the following statement? Okay, so we have an and that is separating them, okay? So just chill out with the and. Let's figure out, is this true or false?
That is totally wrong.
Is the square root of 16 equal to -4?
No.
If we put the square root in, it is, right? Because -4 times itself gives you 16.
The whole thing is so false, though.
Okay, so we're going to say that this is true. We're going to say that the square root of 16 is -4 because if we put the square root in, that is a true statement. All right, so this and, is this one true or false?
No.
False, right? 2 is not less than that. So if we're looking at the truth value of the whole thing,
False.
is this and this true?
No.
No, so the whole thing is false, right? Now what if that said or instead?
Yes, that would
Okay,
be correct.
so if it said T or F, maybe if I write that off to the side, is this or this true?
Yes.
Yes, so that whole thing would be true. So an or, only one or the other has to be true. For an and, both of them have to be true in order to be true. But the answer here is false. I'll put that in a different color. Okay? Happy with that? You know how that works? Okay. Suppose P is true and Q is false. What is the truth value of this thing right here? Okay, so let's talk about what this thing means. What does the V mean? Or. The V means or, all right? Okay, so if P is true, what does this little squiggle thing mean?
Opposite.
Opposite, okay? So we're looking at false, right?
Yep.
Not
False.
P would be false, okay?
And true as well.
Q is false, so not Q would be true, okay? So false or true.
It's
Is
true,
this
the whole
or this true?
Totally is.
The whole thing is true. That's like the example that we just got into doing. I should have saved my breath, right? There you go, number 18. Got it? Questions about that?
It says fort.
What?
Says
It says fort, yeah, you're right. 19, write the statement all dogs have 4 feet in if-then form. So if
a dog.
something, then something.
If dog have 4 legs.
If it is a dog, you can write if dog, that's fine. Then it has, whoa, yeah, it just shorts out on me all the time. Then it has, oh come on, has, there we go, 4 feet. There you go. If then form. If it is a dog, then it has 4 feet. Now, don't try to switch it around in the other direction. Try to give it to me in the same order, because if it has 4 feet, then it is a dog is not necessarily true. Right? Yeah, true.
You're not wrong.
Okay? All right, so there's number 19. Happy with that?
Yes.
Okay. The next two are going to be the law of detachment and the law of syllogism. So I'm going to write out the pattern for the law of detachment, okay? Detachment goes P, then Q, and then they'll give you a P, and they want you to tell me Q. Like this is what we have to like come up with, okay? So if it is raining, I will bring an umbrella. It is raining today, therefore I will bring an umbrella, right? Like it's just saying the same thing over again, okay? That's the pattern for the law of detachment, PQ, PQ, okay? So if two angles are supplementary, that is P, then their measures have a sum of 180. That's Q. X and Y are supplementary. That's P again. So what do we conclude?
The measurements have a sum of 180.
Yep.
And the measure of 180.
I'm going to say angle X and angle Y have a sum of 180. Okay, so they're giving me in general, supplementary means 180. So specifically for angle X and Y, that means specifically they have a sum of 180, right? So this is our conclusion. PQ, PQ. That's the Q part.
I feel like it would be better called the law of reaffirming.
Yeah, right, kind of, yeah. I don't know. Okay, the law of syllogism. This is where we skip over, who is it, Michael?
Yep.
Because we don't like Michael. And in the 5th grade class, we skip over Eli, okay?
Right.
All right, so this is P, then Q. They will give us that. And then they'll give me another statement that says Q, if Q happens, then R happens, okay? That's what they'll give to me. My thing that I have to come up with, we cross out the Michaels or the Elis, and we go straight from P to R, okay? That's the law of syllogism. That's the pattern, okay? All right, so our statements are, if today is January 1, that's P. Q is, then it is New Year's Day, that's Q, okay? If it is New Year's Day, that is
School is closed.
Q again, right? Okay, then school is closed, that is R. So what conclusion do we want to make?
Today's January 1st and school is closed.
Yeah, we want to cross out the New Year's Day. So if today is January 1, then school is closed. Okay, we go straight from P to R. Got it? Pretty easy so far? Okay, all right.
Oh, I love these things.
You love these things. I feel like we're gonna have to write down some of these though.
I don't remember what it's called.
Angle 7 and angle 15. Angle 7 is this guy right here. Angle 15 is this guy right here. Those are? Those are corresponding angles. Corresponding. Okay, should we write out some angle pairs over here off to the side?
Yeah, let's do it.
Okay. All right, so let's just look at this segment right here, okay? We said corresponding was angle, I'm going to say 7 and 5, or 7 and 15. Okay? What's another thing that we could have?
Alternate interior.
Let's do alternate interior. Give me a set of alternate interior. 8 and 14, sure, or 7 and 13. Okay, I'm just going to list one of them to save space. Can we do that?
Yeah.
Okay, let's do an alternate exterior for that intersection. 6 and 16 or 5 and 15. We'll go 6 and 16. Okay, that's an alternate exterior. Okay, we have some consecutive interior. Consecutive interior would be what? 8 and 13 or 7 and 14. Okay, all right. I'm gonna also put in there vertical angles.
Like 8 and 6.
Yep. And there's a bunch of vertical angle pairs, right? 8 and 6 is just one of them. There are actually like 4 pairs of vertical angles, right? So any of them that are across from each other are all vertical angles, okay? Now, there are a lot also of linear pairs. Okay, so give me one linear pair. What?
16, 15.
Sure, 16, 15 is one. They're on the same line. There's a ton of those, right? Linear pair means they're on the same line. Got it?
Would you
We
write
do
out
16.
What?
16 pairs.
There would be 8 pairs. Because these two would be a pair, 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 and then above it, these two, these two, these two, these two.
1, 2, 3, 4.
Right? Say, okay? So those two, these two, these two, these two. That's 4 pairs.
Each on each one.
Yeah, but so if you're counting these over here, yes, then you would have 16. Yes, exactly.
I was going for a whole, man.
I was just going for the ones that we're looking at. Okay?
So there's 6 of those things, right? You just said that.
What?
6 of them?
6 things. Yes. I think that's it. Is that all the angle pair relationships that we've talked about? Maybe. Okay. All right.
Angle 3 is 90.
Okay. Okay. Oh, now this one refers to the same diagram. So let's go back here. I'm going to erase my stuff. If M and N are parallel, so these two guys are parallel to each other, if that is true, and 86 is angle 8, find the measure of angle 13.
This angle 8.
It will be
13. Okay? All right. You only have 2 options for parallel lines. It's either 86 or it's 180 minus 86. Right? So is it 86 or is it going to be 94?
94.
86 or 94. It's going to be 94 because those two are consecutive interior, which means they're not the same measure. So 94 degrees. Got it? These ones should be nice and easy, right? Hopefully. Okay? All right. Now we have another one. One more that refers to that problem. Okay? And it says, given M and N are parallel, so we're assuming that those two things are still parallel, okay? Angle 4 is 6x minus 5. Okay, that's what angle 4 is. Angle 10 is 5x plus 8. And angle 9, holy cow, angle 9 is 3y minus 10. This is a lot.
So the 4 and 10 one equal to each other.
Okay, so the 4 and 10, yeah, those are equal to each other. Those are alternate interior, right? So those x's are equal to each other. So I have 6x minus 5 equals 5x plus 8. Do you agree with that? This guy and this guy are the same? The catty corner ones? Okay, let's solve. So minus 5x. And can I add the 5 at the same time?
Yes.
Okay,
X
so
equals
x
13.
equals 13. Perfect. Okay, now how do I solve for y?
Where's y at?
Right here.
We gotta find what 10 is, or what 4 is, I guess.
Yeah.
Then
So let's find what 10 is. If I plug 13 in for x here, what's 5 times 13 plus 8?
73.
Is it? Really? 5 times 13 is 65, plus 8 is 73. Yep, I agree. So this is 73 degrees, which means angle 9 has to be how much?
180 minus 73.
Like
107.
107? So now we know that 3y minus 10 has to be equal to 107. Are you keeping all that straight? Does that make sense? Okay, let's add the 10. So 3y equals 117 and divide by 3. So y equals 39. I agree with you, yes. Okay, all right, make sure we didn't have to plug back in. Find the values of x and y. We're good. Okay, good? Happy with that? Okay, now we got lots of algebra 2 stuff, or algebra 1 stuff, really. Find the slope of the line that passes through these two coordinate points.
Y equals
Okay.
X plus B.
Yeah, that's slope-intercept form, so they're not even wanting the whole thing, they're just wanting slope. They're just wanting the
We
end,
just
right?
gotta do it to find it.
How do you find, yeah, you would have to do that to find it, but we don't have to find the whole thing. How do you find m? Or slope?
y1 minus y2. That
Yep,
thing.
y2 minus y1 over x2 minus x1. That's the formula for slope, okay? So if we're using those two coordinate points, what's your second y coordinate?
9.
9 minus?
Negative 6.
Plus
Oh.
6.
No,
I mean,
no.
14.
9 minus 14, because those are the y's, right? Then we do negative 3 minus a negative 6, or plus 6. I'm going to write it as minus a negative, so that way you can see it in your notes, okay? All right, 9 minus 14 is negative 5, and negative 3 plus 6 is going to be positive 3. Don't change your slope to a mixed number. Leave it as negative 5 over 3. That's my slope, okay?
Sounds like a gross slope.
I mean, it's down 5 over 3, whatever. Okay? All right, 26. Determine whether. So CS is making a line and KP is making a line, okay? And they want to know whether they're parallel, perpendicular, or neither. Let's talk about parallel
Oh, I remember these.
versus perpendicular. Did we do this yesterday?
Parallel, they have the same
No.
Okay. We did this a lot in my algebra class then.
Opposite, right?
Okay, what?
So for parallel, they have the same slope.
Same slope, okay?
And then perpendicular, they have the
Negative
opposite
reciprocal.
Yep, they have the negative reciprocal slope. Okay? Negative reciprocal slope. So that's how the slope thing works, okay? So we have to find the slope between these two, and we have to find the slope between these two, okay? So we're going to do the same thing as what we just got into doing. y2 minus y1, x2 minus x1. Okay, I'm going to move him over. All right, what's your second y coordinate for
4
CS?
plus 12.
4 minus a negative 12, yep.
And 5 minus 1.
And 5 minus 1, okay?
So
All right,
16
so
over
4
so
plus
4.
12 is 16 over 4, which is
3.
4.
Oh, that's a 12.
16 over 4.
My
Alright.
guess is going to be a perp.
Okay,
My
now,
guess.
if it's going to be parallel, his slope is also going to be 4, right? If it's going to be perpendicular, what's the slope going to be?
Negative 1/4.
Negative 1/4. Okay, so that's what we're looking for. All right, we're doing negative 6 minus 9. And we're doing
Negative
6
15.
minus 1. Okay, this is negative 15 over 5,
Oh no.
So now
which is negative 3.
Neither.
That's a neither one. Hey. If you get neither, I always go back and like check real quick to like make sure I didn't do anything wrong, because, you know, but we didn't do anything wrong.
Second.
So that's an either one. Okay? Good? All right. Okay,
Writing
now we're going to do what
equation.
Gabe said. Slope-intercept form. What is slope-intercept form?
Y
equals
equals
mx
mx
plus
plus b.
Y equals mx plus b. Okay, so we need to find the m, which is the slope, and we need to find the b, which is the y-intercept. Okay? All right, of the line that passes through this and this, which one do we find first, m or b? M, right? And we know how to find m. y2 minus y1. If you don't want to write this formula down again, you don't have to. x2 minus x2 minus x1. Okay? All right, what's your second y?
5 minus 3.
5 minus 2.
I mean, that's what I meant. Equals 3.
2 minus a negative 4, 2 plus 4. So your slope is going to be
Half.
3 over 6 or 1/2. Okay? All right, now I'm going to write out what we have at this point, which is y equals 1/2 x plus b. And the only other thing I have to find is the b. How do I find the
5
b?
equals above the thing.
Which one?
The second one, because it's nice.
Okay, so you can plug either one of them in, but 2, 5 is going to be the nice one. So make sure 5 goes in for y and 2 goes in for x, right? Okay, what's half of 2?
1.
1 plus b, okay? Then I solve for b, so minus the 1 over,
4.
b is 4, okay? Final answer, y equals. Yep, 1/2 x plus 4. Good? Got it? That's not too bad. Holy cow. We're rocking right along. Okay? 28. Can I go down?
Yeah.
28? 28. Write the equation of the line that is perpendicular to this thing. Okay? Alright, again, perpendicular versus parallel.
Y equals 3x. Negative 3x.
On the test, I may ask you for parallel, and parallel is actually easier. Parallel, you use the same slope. Perpendicular, you use the negative reciprocal slope. Okay, so what is the slope that they gave me?
A third.
1/3, right? So if they're asking for perpendicular, which they are, what's the new slope going to be that I'm going to use?
Negative 3.
Negative 3, okay? If they were doing parallel, which they're not, but if they were, what slope would I use?
A third.
You would still use a third, right? Okay, so just in case on the test I do parallel instead of perpendicular, there is that, all right? So this one is perpendicular, so I'm going to start with y equals negative 3x plus what? B, right? When do I use this negative 2? Where does he come into play?
He's just gone.
He doesn't. He's gone. You never use it. The only thing that you use from the original is the slope, okay? And we need to find b, so we plug in 6 and negative 1. So 6 equals, this would be a positive 3 plus b. And let's
So
minus a 3, so b is
3.
3. And then final answer, y equals?
Negative 3x plus 3.
Perfect. Negative 3x plus 3. Good, 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 good. Got it?
Unfortunate.
Unfortunate. All right, find the value of x so that a and b are parallel to each other. All right, a is here, or one angle's here, one angle's here. Are they the same measure as each other, or do they add up to be 180?
Alternate exterior.
They're alternate exteriors, so they are the same as each other, and we can set them equal. Okay? You only have 2 options. They're either equal to each other, or they add up to be 180, so make sure you just pick the right one, okay? So we have that going on, and then let's subtract the 6x,
And add the 44.
and add the 44 at the same time? Sure. So we've got 3x equals 54, and if we divide by 3, x is
18.
18. I believe you. All right, find the value of x, so we don't have to plug back in. I always go back and check. 18 is what our answer is. Okay?
Let's just do it.
Should we do some more? Should we just do chapter 3? We'll get through 33 and then be done. Oh, we do have to do some proofs tomorrow.
Yeah, let's do it.
Yeah, so let's go through chapter 3. We'll get through 33, okay? And then we'll stop as soon as we get to 34. So we'll do that one. Okay? All right, name the transformation that we'll take. Okay, let's, should we put some stuff off to the side over here? Transformations. Okay, so the 3 types of transformations are, the first one we did was a reflection. Okay, and we had 3 types of reflections. They were x-axis reflection. Okay, and what happened to the coordinates when you reflect across the x-axis?
X, Y, X, and the negative X. No, negative Y.
Make the second one negative.
So you just make the y coordinate negative for x-axis. For y-axis, you make the
X negative.
x coordinate negative. Okay, and then we also did like y equals x, the line y equals x. I don't know if I'll give that to you, but what happens if you do it across the line y
They
equals x?
swap, right?
They swap places, so it's just yx, right? You don't make either of them negative, but there's how that works, okay? The second thing that we talked about was translations. What's a translation?
Slides.
A slide, okay? So it will just do one of these, and this will be left or right, and this will be up or down, depending on whether they're positive or negative, okay? And then you just add those coordinates. So I'm gonna say just add. Okay? The last one that we had was a rotation, and these were the hard ones. Kind of, maybe, just harder to remember. We had 90-degree rotation, 180-degree rotation, and 270-degree rotation, all of them counterclockwise. That was like embedded into the rule. Okay? All right, 90 and 270 are similar to each other in that they flip, right? Yx and yx, but which one becomes negative? 90 is the y, it's the first coordinate becomes negative, 270.
Is
The second one, because 270 comes after 90, right? What happens with 180?
X, Y, make them both negative.
Yeah, x, y make it both negative. Because 180 is the same thing as these two together, right? X and y axis reflection. That's what 180 is. Whoa. Okay,
Can you slow
so
down a second?
I'll let you get those all in there. So those are the rules for your transformations. All right, let's write some stuff down. Are you ready for the first one? Number 30? Name the transformation that will take this thing, I have a typo, 2, that's not supposed to say ton, this to this. Okay, so we have flipped them around, right? If I flip -4 and 2 around, that becomes 2, -4, right? So I flipped them and I've made this one become negative. So what rule is that? This is flip, and the first one becomes negative. So it's like negative yx.
The y-axis.
90 degree.
Oh wait,
90
no,
degree.
flip.
This is a 90-degree rotation. You see how that works?
No.
I have flipped them around, okay? And if I flip them around, I get 2, -4, right? But I want -2, -4. So I flipped them and also made the first coordinate negative, which is a 90-degree rotation. Does that make sense? All right. Okay, now they give us coordinates, and they want after it's reflected across the y-axis. Okay, so I'm going to write the rule for y-axis down here. Y-axis, you just make the x negative. Negative xy, yeah? Okay? All right, so x prime, y prime, and z prime. Okay? You're just making the x coordinate negative. So what's x become?
1, 1.
Just 1, 1. Yep. Y,
1, -2.
1, -2. Yep. And z,
-3, 3.
-3, -3. Okay? That's it. Not too bad. Okay, 32. Translated along the vector 5, -4. What does the 5 do?
Moves it up 5.
No.
Right 5.
Right 5, because the x coordinate goes left and right. Okay? The 4 is moving him
Down.
down 4. Okay, so we're just doing 5, -4 to each one. So 5, -4, 5, -4, 5, -4. I don't care if you write these down, whatever. A prime. If I'm adding 5, -4, that will be 5, -5. Okay?
Why did they go A, B, Z?
I don't know. B,
7, -4.
7, -4. Yeah, it does. That's weird. Okay, Z prime.
8.
I'm guessing that's a typo too.
7.
Whatever. Okay, yep, 8, -7. Perfect. All right, last one. State the order and magnitude. Okay, what's order mean?
The amount of time that it has to spend to go back to where it was.
Number of times to spin. Does that make sense if I write it like that? Number of times to spin around. And the magnitude is 360 divided by the order. Okay.
It's just 60.
Yep. So this one, this is kind of hard because people get confused when it gets to be like hexagonal shapes and stuff like that. So like this guy would have to rotate to this side, right? Then it would have to rotate to this side. Then it would have to rotate to this side. Then it would have to rotate to this side. Then I have to rotate to this side. Then I have to rotate back to this side. That is 6 rotations. Yeah? So the order is 6. Magnitude, yep, you're right, is 360 divided by 6. So that means that from here to here is 60 degrees, and another 60 degrees, and another 60 degrees, and another 60 degrees, right? Till I get back to the beginning, okay? Those are all 60s. Okay, good? There's the order of magnitude. Yep, got it? Perfect. All right, there you go. That's all. Chapter 4 is what we'll start tomorrow, 4 and 12. And that's it. Holy cow. Oh, and the proofs. We got to do the proofs tomorrow. Okay? We'll go over those different types of proofs. Okay?
Why did we skip like 5 and, or are we gonna go do them? Will we do
What?
them? Will we do like 5, 6, 7, 8, 9, 10, 11 when we get back?
Yeah.
What?
Yep.
We like,
Oh, the
We go to chapter 12 when
we started with chapter 12. Like,
we started with chapter P and then we go to chapter 12 or chapter 0 and then we go to chapter 12 just because like seniors, sometimes I'll have seniors in geometry and there'll be lots of probability on the ACT, and so if those seniors want to take the ACT one last time before they graduate, I want to make sure that we get it at the beginning of the year. So all right, goodbye people watching this.